Hello, welcome to the fourth talk in the Vision Revolution series at the Junction, the Clonmel Junction Festival. I'm Anne and this is Dennis and we're the School of Looking.
So today, you may remember we're talking about all the light in the universe, most of which is invisible. But today we're going to be talking about the visible light, the visible spectrum.
The visible spectrum, and what is that? Well, it's electromagnetic radiation like X-rays and gamma rays that we talked about before.
And UV.
And UV and infrared and microwaves and radio waves, all of these things. But this is the part that is actually visible to our retina. In fact, when it's the wavelengths that when they impact our retina, they are transformed into visual information.
And it's right in the middle of the spectrum.
Right in the middle. The wavelengths, in fact, are somewhere between 380 nanometers and 740 nanometers.
So that's tiny.
They're pretty short, yeah. A nanometer meaning a tiny, tiny little bit of a meter.
So you may remember the very first talk. If you saw our very first talk, we talked about Isaac Newton, and we talked about how he split white light into its constituent colours, and those colours would represent that whole range of that Anne just spoke about, the range that's visible to our eyes. And he went on then to write a treatise.
That's right. And Isaac Newton described his understanding of light based on his experiments in a document called Optics in 1672, Optics with a K. And that really became the basis for understanding light for everybody in the scientific world.
For a century at least.
More than a century, yeah. But more than 100 years later, Johan Wolfgang von Goethe.
So he wasn't really a scientist, he was a universal man, wasn't he? Really a writer, a philosopher, mathematician.
A politician as well, and a painter, a talented painter. He was a sort of universal man, really. And he was really interested in colour. And he did a lot of studies of colour, a lot of experiments in colour himself. And he wrote his own theory of colour in 1810, which really disputes the Newtonian concept of colour.
Which was Newtonian concept was colour is pure physics, whereas his was about perception, really,
it was
wasn't
about perception, yeah. He started to observe. At the time, people were designing colour wheels to try and lay down the relationships between a lot of colours. And the Newtonian earlier ones, a century later, have been really quite diagrammatic. They divided colours up into quite strict zones that were with sharp edges. And Goethe himself designed a new colour wheel, and it was a very subtle colour wheel. You can see it if you look at this. You see how there's like a lot of sensitive gradations and evolutions. It gently really develops from one colour right around and back to itself.
I think this is subtractive colour, which is painted colour.
So
I think that would be the implied. So where the three triangles are superimposed, the blue, the red, and the yellow, they make black. And of course, blue, red, and yellow are painters' primaries.
That's right. That's right. He was really looking at it from a more, perceptive point of view, because he considered that colour. He observed really that colour was not just objective, but it was related to a lot of other phenomena. So if you had one colour beside another colour, then that would change the perception of that colour. Or if you colour in the dark or colour brightly lit, that would also change the way you saw the colour.
Right.
So there was a conversation going on at that stage about what colour might be.
And that conversation continues to this day, doesn't it? Really, in fact, I mean, when we look at our theory of colour now, we still talk about it in terms of colour wheels and it.
That's right. That's right. McCune defined his own colour space, which is actually relatively simple, isn't it? Except it's in three dimensions as opposed to in 2 dimensions.
Yeah, which still wouldn't make sense in terms of Newtonian physics, because Newtonian physics, it was a linear, the spectrum was a linear thing. It wouldn't have turned back in itself.
So explain here, how does McCune transform the 2-dimensional colour wheel of Newton and Goethe into this 3-dimensional diagram?
Colour space, yeah. Well, so this would be really the contemporary theory of how the eye works. So it works by oppositions of blue and yellow, which, as you know, would be complementary colours, green and red, and black and white. and it seems that the optic nerve, not so much the retina as the optic nerve, works by sending signals of these oppositions of blue, yellow, red, green, black, white.
Okay, that's really, really interesting. So we're talking about colour complementaries.
We're talking about Johan Wolfgang Goethe.
So he published his own theory of colours in 1810, and this disputes the Newtonian notion of colour as being a measurable phenomena. And so he said in this, he wrote, "Along with the rest of the world, I was convinced that all colours are contained in the light. No one had ever told me anything different, and I'd never found the least cause to doubt it, because I had no further interest in the subject. But how I was astonished as I looked at a white wall through the prism that it stayed white. That only where it came upon some darkened area it showed some colour, then at last around the windowsill all the colours shone. It didn't take too long before I knew that here there was something significant about colour to be brought forth, and I spoke as through an instinct out loud that the Newtonian teachings were false." Now, I don't think he's quite right that they were false. I think Newton, a lot of his teachings or his deductions were correct, but he didn't understand that notion of comparative. Of
contextuality. Yeah. Because when you look at the thing from a contemporary point of view, this is a very famous optical illusion that we've seen often. The chessboard with the shadow over it, and the square A and the square B. The square B appears to be white, the square A appears to be dark grey, but in fact they're the same colour. And this is a...
Do that again?
So square A and square B,
so square
it's clearly A looks darker
works.
than A.
Yeah. B looks almost white in a slight shadow, but certainly lighter.
And then you discover they're the same colour. So your eyes really base their judgment of colour on context.
So, I mean, even back then, I mean, people were really, concerned, or they were aware that colour, there was an emotional or psychological aspect to colour. And Goethe at the time, he had even designed what he called the Rows of Temperaments, which was a colour wheel that illustrated human occupations and character traits. And so he had, different colours, including, to represent people, including tyrants, heroes, adventurers, hedonists, lovers, poets, public speakers, philosophers, teachers, etc., grouped into 4 temperaments, or types of temperaments related to colour.
Right. So this would have represented a kind of opposition to the purely physical notion of colour of Newton.
That's
a psychological notion.
Aspect. And then he had a student called Arthur Schopenhauer, who he met actually. Schopenhauer's mother had a salon.
Oh, yes.
He met him at the salon. He met Goethe at the salon. Goethe was much older, and Schopenhauer learned a lot from Goethe. But then their perception of colour diverged, and they fell out. Actually, he wrote his own theory of colour called On Vision and Colours. Schopenhauer in 1816. So only 6 years actually after Goethe had published his.
But he was very much a younger man, and he began as a student, and then
because Schopenhauer at the time maintained that the eye was active. In fact, he said the eye's reaction to external stimulus is an activity, not a passive response.
So that very much would connect up with contemporary theories of perception. You look at a lot of the work that we've done with scientists. In the last 10 years, we've been working with researchers into perceptive psychology quite regularly. We're going to look at one of them now. We're going to talk to one of them now. You look at somebody like Richard Gregory's Eye and Brain, and essentially they're working on the eye as something that's part of the brain, really. And then beyond that, they're working on the idea that the eye is a constant conversation between the brain and the world. So it sounds very much like Schopenhauer.
But Schopenhauer wasn't quite there, because he himself thought the eye was the active organ, or at least that's what he seemed to suggest.
And I mean, they wouldn't have had, now we have much more of an idea of just how much of the brain is taken up with dealing with the information coming from the eye, and dealing with giving commands to the eye, and it seems like it's about a third of the brain, which is an we have the privilege of having a long, ongoing conversation with a perceptive psychologist called Kevin O'Regan, and he's spoken to us about this recently. We're just going to show you quickly what he had to say.
When you look at a visual scene, most people think that what's happening is that you're creating this internal picture.
Mm-hmm.
And my theory about vision, which is developed from my studies of eye movements, suggests that it's not an internal picture that you generate, it's what I should say, internal knowledge. But the knowledge is not like a picture. The knowledge is knowledge about what is in the scene. And it's more in an abstract form. So if you look at a scene, what you see, or what your brain essentially gathers from looking at the scene, is not what a cameraman would call pixels. Mm-hmm. It's not like a photograph. It's knowledge. It's stuff like, well, the couch is red, and it is to the left, and it is in the lower part of the scene, and behind it there is this. So it's a description rather than being a picture. Mm-hmm. But the thing is that the brain is very limited in its memory and limited in its attention. So when you look at a particular scene, visually, because there's all this stuff coming in, you have the impression there's lots of stuff there, but actually you really only register a semantic, abstract description of the scene. And because your brain is very limited, your attention span is very limited, that description is also very limited.
So your impression that you see the world in fantastic detail is an illusion.
Exactly. Your impression of seeing a rich visual field derives from the fact that if anything should change, you would immediately become aware of it because it attracts your attention. But that doesn't mean that you have internally stored everything that's in there. In fact, this idea could be summed up by saying that there's no need for you to make an internal picture of your outside world, because the outside world can be referred to as though it was an external memory. You know, if you want to know anything about the world, well, just turn your eyes towards it, and you can get it. Why bother to make an internal picture?
The world as an external memory that your brain accesses constantly through your eyes, or that your brain has the constant possibility of access to through your eyes. That's a fascinating idea for artists.
Incredible idea, absolutely, and philosophers and scientists, I think, and anybody who thinks about these things.
Mm-hmm. And the idea that really you don't form any sort of internal picture of the world, that's an illusion.
Because it's all there. It's all there around you, so you can just quite simply refer to it. Mm-hmm. Mm-hmm. Uh-huh.
So a colleague, we'd like to turn now to look at a project that we've done with a colleague of Kevin's. His name is Patrick Kavanagh. Nothing to the poet Patrick Kavanagh. The Canadian researcher Patrick Kavanagh, who came from Harvard School of Psychology to Paris Descartes, the laboratory which Kevin was directing, and we did very recently did a project with Patrick in the Tate Modern.
I think art is really visual experiments, and the artists are exploring different ways to present scenes or ideas, and they come up with insights and discoveries that are very important for vision science. So we've done a lot of studying of what artists have discovered over the centuries and millennia. And there's just some wonderful insights into what shadows are and what reflection is, and things that are hard to understand in the brain that artists have understood intuitively how to capture these properties in the visual world. And so there's some things that artists understand and that the brain understands, but the scientists don't understand yet. So we do study artists, we see how they know what they know, and study art as a sort of discovery of science.
So are you trying to reverse engineer what the artists are doing?
Absolutely, yes, it's really good. Some artists know exactly what they're up to, like Dennis and maybe James Turrell, a couple of them.
I'm not sure I'd include ourselves, James Turrell.
And they really explore perception and then make it part of their art. Other artists just fall upon things and are amazed at it, and then we are as well, trying to, as you say, reverse engineer.
And for the artist, is this a new repertoire of phenomena or visual enhancement that you can go for? I mean, you're always trying to give people something visually new and intriguing.
Yeah.
Does the science help?
Yeah, I mean, for example, what we're showing here is the equiluminance helmet, or what we call the equiluminance helmet, and that's based on something that Patrick's been exploring for about 30 years now, isn't it? But for us it was totally new, but quite difficult as well. It took us quite a while to get a handle on it. I remember the first time you showed it to us was the turning frog, wasn't it? And you know, you looked and you thought you saw a turning frog, and then you tried to focus on its head and you realised you were looking at its butt, and suddenly it would just turn around, and it was quite a shock, really, to discover that your eyes were not telling the truth.
I think there were some artists who, this is presenting images in pure color with no variation in light and dark, and there were some artists who did that. It's not Bridget Riley, but
James Turrell.
And James Turrell, yes, of course. So it's just fascinating to think about what the part of the brain is doing that sees only color and what it's capable of. And now you can go and take a look.
That was at Self-Impressions in 2018 with the University of London. And it brought together several researchers and departments of psychology as well to explore how we perceive ourselves and see ourselves through a whole lot of different experiments.
And our own contribution to that show was a series of helmets called the meta-perception helmets, most of which are very well crafted by the craftsman Neil Mackenzie, and each of which is a sort of an experiment of vision. And one of them was not done by Neil at all. It was a little piece of...
As you can tell.
It was a very, very, very crudely made bit of DIY, a prototype really, and this was based on an experiment that Patrick had done a long time back. What we'd like to do is tell you the story of how this project, which has lasted for a long, long time, because it originated back in the 1980s, didn't it? This is the paper that Patrick published in 1991. In fact, if you look here, it was received in August 1989. So about 20 years after that, we first met Patrick.
And so it's called Vision with Equiluminant Colour Contrasts. Now that's very, very complex title. I don't think anybody, ourselves, we don't really understand it. But what he's talking about really is motion perception in certain lighting conditions, essentially, which we won't really go into. But he was very interested, Patrick, in separating out the components of vision. Isn't that right?
So that when we met him, in fact, he was interested in the work that we were doing, which was being shown in the Pompidou Centre at the time, a series of installations where we separated out motion from video, pure colour from video, profiles in video, and he was very interested because it corresponded with a lot of what he'd been doing.
We didn't really realise we were doing these explorations as aesthetic ideas. We didn't really realise that it was represented a long history of exploration into vision at the time at all. But Patrick saw the connection.
And he invited us to his lab and in 2011 and showed us an experiment based on his research that he'd been working on for 20 years. And this experiment worked with yellow light and blue filters, and the vision of the world that it gave amazed us. So we were, at the time, we were just drawing our helmets, our meta perception helmets, and we drew a version of Patrick's equiluminance project as a helmet, as the equiluminance helmet. And Patrick was very keen that we do this and said, go ahead.
Yeah. We had actually drawn about 25 different types of helmets that you could wear that would explore different scientific aspects of vision.
And we ended up building about 7 or so, wasn't it?
Yeah, we built 6 or 7 of them, but we really didn't build this one because it was extremely complicated and we didn't really know how to do it. In fact, we had sketched it.
Yeah, and it involved a lot of very subtle work with colour and with colour filters and with electronics. So it remained on the back burner for a few years. And finally, in 2016...
That's right. Bo was Salambo, our daughter, was 15, and she had to do a work experience program. And so we asked, and she's interested in science, well, she's studying mathematics now, and we asked Patrick, could she go into his lab to do her 2-week experience? And he said, sure. And
when she turned up, Patrick said to her, what you're going to do, Salambo, is you're going to build this helmet that your parents have drawn, and Salambo's eyes widened, and Patrick said, "Don't worry, your parents will help you."
And so she came home, and she's a typical teenager. She said, "Oh, he wants me to build a helmet. Do I have to?" And we said, "Well, yeah."
So we did help her, and we worked with a fairly minimal budget, and the 3 of us built the helmet using
with a lot of help from Patrick about how to do it. Really, the actual experimental setup of how to bring the light up and down and all of that. He advised us.
And at the end of the summer, we had a working version of Patrick's experiment, which Patrick tested and was delighted with.
Absolutely.
Yeah, there was a conference on colour vision, which was which Patrick was invited to, and all the main researchers from all the universities of the world working on colour vision were there.
That's right.
And Patrick bought Salambo, who demonstrated the helmet for all these researchers. All of them were interested. None of them agreed with what it was doing, about what it was doing. There was strong disagreement about exactly what was going on, but they were all interested.
So after that, Patrick then approached us and said, maybe we could write a paper on it. And he said, what I'd like is that if Salambo will write her experience, and then we'll see what we can do with that and see if we can get it published. And so she did. She wrote down her experience, and then together, Patrick put in more scientific aspects, and we contributed parts of it. And Laura Herman, who's another one of Patrick's PhD students, also contributed. And together we put together this article that was published with Salambo, who's only 16 at the time.
And Patrick, who was a prestigious researcher at the end of his career, being the generous man that he is, proposed that Salambo's name be put in as the principal author, and his name be put right at the bottom. So after a long process of peer reviews and rewriting and rereading and rewriting, the paper was published in Eye Perception with our 16-year-old daughter as its principal author, and that was the generosity of and still is the generosity of Patrick Kavanagh. He put his name at last on this paper.
That was for us a really important experience, because we'd never collaborated on a scientific paper before. Neither had Salambo, and what was really interesting was to see the way everybody works together, to deliver this thing. And there's not a lot of ego involved, which was really a very, very impressive experience. I mean, Patrick very generously put Salambo forward, even though she was the youngest person. And then, we had the whole experience of the rewriting and the peer reviewing and all of that, and so did Salambo. So it was a really big learning experience. You learn to appreciate how really challenging it is.
While we were writing this paper, we received a visit from a famous musician.
That's right, David Byrne. Some of you may know who he is, and well, he's a pop star from the 80s and 90s. So maybe a lot of our audience will have never heard of him.
Lead singer of Talking Heads.
That's right, Talking Heads.
Well, how did I get here? Letting the days go by, let the water.
And so he came to Paris, especially to see. Well, we thought he'd come to see our meta-perception helmets, these metal ones, and so we demonstrated these to him. But actually, in actual fact, he was much more interested in the other helmet that we'd made with Bo, the Equiluminance helmet, because he himself had already started to develop a project called Theatre of the Mind, and he wanted to work with these perceptual experiences in this.
So he was preparing this project in New York on Governor's Island, an extraordinary series of rooms with each with an experiment that worked with human perception, and he wanted the Equiluminance helmet to be part of that. So we eventually
the Equiluminance helmet is it's very difficult to show in an exhibition situation, because people have to put it on, and then they've got to transform the light, modulate the light, and then there had to be.
You need someone to help you, to explain to you what it's doing, to help modulate it exactly to where it needs to be.
Exactly, and people, sort of, you don't want people to be, in the dark, bumping into things or whatever. So it's a lot of things to think about.
Yeah, and you've got to think about exactly what you're going to be looking at too. You can't just wear it anywhere. So it was quite tricky, as were all of the experiments that David Byrne's Theatre of the Mind was showing.
So this is a workshop essentially to try and figure out all those aspects, to try and work out how we could really show this in the actual final exhibition.
And that would have happened in October 2017.
That's
we were
right,
in New York. We were when we arrived there, we thought we were going to be building a beautiful version of our prototype that was finally finished, and as finished as the rest of our meta-perception helmets were.
And
but
of course, our aim as artists is that we will make a beautiful thing out of this as well. I mean, the experience is important, but the experience of the spectator looking at the object and the experience is also as important as wearing it.
So we were planning on something very well finished and very, very well thought out. As it happened, they were very keen on the DIY aspect of the thing being kept. They wanted lots of them. They didn't have much time, so we ended up working kind of in a sweatshop in New York, didn't we? To build
unpaid, but for the glory of art,
to build
and science.
Making a production line of Equiluminance helmets for David Byrne's Theatre of the Mind, and meanwhile working on the building of the room and the various things, the wheel.
So the thing with this helmet is you have to have something moving in a regular fashion, so that you can then judge that the movement is changing. So ideally, a turning wheel. So we had to build a wheel, but it had to be big and rotating.
And that the litmus test of this helmet, if you like, was that the turning wheel appeared to stop when you got to Equiluminance.
But we thought it'd be interesting if we could look at people's movement as well and other things. So we were trying out lots of things. I mean, I think David Byrne usually he dresses better than this. But
we discovered the stripes work well with
stripes
it,
are good.
and we tried probably fairly unsuccessfully to include stripy clothes in the
that didn't really work too well.
We also tried having mannequins turning on displays, on shop displays,
rotating figures, mannequins. Then of course when health and safety regulations came in, they said no, people will trip and fall, so people ended up having to be sitting down. So really we were coming up against all these different constraints about how we can show this or people can experience this as an exhibition, which is complicated.
But it was most interesting, and when you put it all together, this was practically the most extensive project that we ever did, because it began with Patrick's research in the 1980s in Harvard. It came to Paris with him, where we met him. It became part of our meta-perceptual helmet series. it became a student project, our daughter's work placement project. It went to a major conference on colour vision.
Yeah.
It became the object of a scientific paper, which was published in 2017. It went to New York to become part of David Byrne's Theatre of the Mind. It went to the Tate Modern as part of Self-Impressions, and it's still running. You know, as the project that we're planning, the show that we're doing.
So we're going to have a new exploration of equiluminance in the visible light area of our exhibition, Invisible Light, but we have visible in there. And we're also going to have a new demonstration of this at the Senses Festival in Biotopia in Munich in October as well. So this is ongoing, this project.
And it also has a new challenge, which is the COVID crisis, of course, because we can't really think about it being a helmet anymore. We've got to make a boot. So
you have to build something. So what's really interesting, though, is that this project has already crossed 3 decades really since Patrick started it, and he's still working on it too.
It's gone from North America to Europe, back to North America, to Germany, to France, to London. It started with a man who's now retired, and continued through the work of a teenage girl.
Exactly. So it's covered, three generations as well. So it's I mean, for us, it's a really, really interesting example of a really good art-science collaboration. I think Patrick has learned things well through us. He got to actually get a wearable, sort of demonstration of his helmet, and now he's using that as well for his further research. So
hopefully we contributed to David Byrne's career as well.
How did I get here? Letting the days go by.
So that's our experience with visible light.
That's the end of this talk. We'll be back to you tomorrow to talk about infrared.
So at the same time. So join us tomorrow for infrared. Bye.
Bye-bye. Thanks.